In this video, we'll be discussing relative extrema. Some books use the word local instead of relative, so if you've heard of local extrema before, that's the same thing. So we have two definitions here. We have two types of relative extrema that we'll be discussing. The first one is a relative maximum. A relative maximum is a function value or a y value. We can see that notation here. This is f of a, that's a y value. A is the x value that gives us that y value. And so this y value is a relative maximum if there's an open interval around that x value where it's coming from, such that this function value that we're looking at is the highest in the interval. Let's illustrate this by sketching a graph of a function. Alright, so we've sketched a function here. This point right there is the one that we're looking at. That is the y value that we're interested in. We're denoting the x value as a, so then the y value is f of a. And so this is not the highest point on the graph, right? This is not the highest y value we see because over here the graph is increasing up toward infinity as we move to the right. But in this little area around that point, it is the highest point. So that's why the definition is saying if you look at a little open interval around this x value a, you look at the points on the graph that correspond to those x values, this point right here is the highest. It's the largest y value. So that's what makes that y value a relative maximum. Then we've got a similar definition here for relative minimum. So a function value is a relative minimum if it's the lowest function value in that general vicinity. So similarly here we've got our y value, f of b. Here's our x value, b. And this is not the lowest y value we see on the graph because over on the left side it's going down forever, but in this little open interval around b, if we look at what the function is doing there, that point corresponding to the x value of b is the lowest one in that little area. So f of b is a relative minimum. Here we have an example of a function that has a few relative extrema. So we're going to look for the relative maxima first. And there's two of those. So first we're identifying what x values are giving us those relative maxima. So we've got one here at this point which has an x value of 0. And we've got another one over here which has an x value of 5. So that tells us the location of where they're coming from. Now what are the relative maxima? Those are the function values or the y values. So this one is 3 and this one is 4. And then we have one relative minimum. It's at an x value of 2 and the relative minimum is 1 because that's the y value.